Will Robinson here from Robinson's Auto and toolsandtime.com. Welcome. Today I'm going to continue where we left off with the last video when I was going over to DVOM and some of the basic checks you can do with them. Today we're going to be putting together a real simple circuit. It's pretty much the same circuit I worked with you in the earlier videos when I used a simulator. We're going to be throwing that together in real time and testing the circuit with a DVOM. Now you may see me using different DVOMs throughout the videos. I can't say they're all the same, but I have a variety of them, so it's just whatever I grab out of my box. And they all, as long as they're a decent DVOM, you'll be able to perform these tests with no problem. Like I said, it's going to be very basic. I just want to start with the basics and work you guys up for those of you who are still at that level. Okay, here's the simple circuit that I just drew up for you guys. As you can see, we've got a 12-volt battery. However, you know I'll be using a 12-volt battery charger as our power supply for this demonstration. However, we'll pretend it's a 12-volt battery, so that's the battery symbol. You got your ground side of the circuit, and you got your positive side of the circuit, so your negative and your positive. Most times in automotive electrical, your ground is going to be black, your hot is going to be red. So negative black, positive red. So you can see on the positive side, I come up. First thing in line here is the fuse. And as you can see, the voltage indicator box says hot at all times, because there's nothing between the battery and that fuse. So if there was a switch there, it would be a different circumstance. However, there's nothing between the fuse and the battery, so that's going to be hot at all times. From there it goes on to the next component, which is a single pole, single throw switch, which you see is open. If that closed, it would continue on to your single filament light bulb. It'll go through your light bulb and then to ground. Now this is going to be sharing a common ground. This is how you'll see it in most schematics. So as you can see, the positive is red, and after the bulb it goes to black. The reason I have it written up like that is because you should never have positive voltage going to ground. So let's get started. Let's build this circuit. My battery charger that I'll be using as a power supply, like I said, it's 12 volt. This is the positive, red, negative, black. So the first thing we want to put in the circuit is the fuse. So I got a 5-amp fuse inside a fuse holder. There's a single pole, single throw switch. This one has an illumination option with it. However, we won't be using that. We'll just be using the single pole, single throw portion of the switch. So it's single pole. So we got the fuse, the switch. I need the light bulb. That I'm just going to be using I got a 194 single filament bulb. I'll be using that for this demonstration. I don't have a holder for the bulb. I'll just be using alligator clips. Now we're on to our negative side of the circuit. Okay, and that's our simple circuit. It doesn't really get much simpler than this. So let's fire it up and see how it works. It comes up from the positive side of the battery charger, the power supply, which is the battery on the schematic, to a 5-amp fuse, as long as that fuse is good, to the single pole, single throw switch, which is open. So I should have power on this side of the switch, but nothing on this side of the switch. If I close those contacts, it should flow through the contacts, over to the single filament bulb, which is attached to ground, so that bulb should illuminate. Let's do a couple quick checks with the meter to make sure I have power present. Okay, I got my DVOM. Not sure how good you guys can see it from there. I got to set the volts. This is an auto ranging, but I have it on DC. Why isn't the bulb lit? Let's just troubleshoot the circuit. How do we go about seeing why that light isn't lit? Well, let's do a simple voltage check and bring us through the circuit. So I'll make sure first that my power supply is working. Like I said, it's a battery charger, so it's going to put out a fluctuating voltage. It ain't going to be exactly 12 volts. It might be close to 14. Let's check it out. I don't know if you can see that there, but I got about 14.3. Let me throw the backlight on. 14.37. So we know that we have voltage present, but we're losing it somewhere. Either the bulb's blown, or the switch ain't on, or the fuse is blown. Let's troubleshoot the circuit using a voltage check. Okay, so I'm going to simply I got an alligator clip set up here, make it easy, user friendly, so I don't have to hold on to this probe. So we know we have voltage. So I'm going to come up from here to the fuse. I have voltage on this side of the fuse. So everything's good on that part of the circuit. The fuse is good. So we go from there, come up to the side of the switch. Okay, I got voltage. But I lost my voltage on that side of the switch. So we know why the circuit's not turning on is because we have no voltage on that side of the switch. So how can we do that in another way? We can do a continuity check. So let's do a continuity check. Now, in order to do a continuity check, you're going to have to open your circuit and disconnect your power. So I'm going to simply just unhook the positive. I'm going to turn the charger off for now. Excuse me. Now we're going to do a continuity check. I'm going to hook this up to the beginning of the circuit. I'm going to set this to continuity. I don't know how good you can hear that, but I have an audible signal. So let's do a continuity check to see where this circuit's open. You know, it's good. The circuit's good to that side of the fuse. It's good on that side of the fuse. So we come down around. The circuit's complete to that side of the single pole, single throw switch. Come over to the other side of the switch. I have no continuity, so the circuit's not continuous to that point. While we got it powered down and the circuit open, and we checked and we found we lost continuity at this switch, let's check the contacts in that switch by doing a continuity check. So like I said, you know our circuit's complete to this point. So let's throw that contact in that switch and see if the switch is good, if the contacts are good in that switch. So now I have continuity, the circuit is complete on the opposite side of the switch, on the other contact, so we know the contacts in that switch are good. So now we can continue over. Our circuit's complete to the bulb. So let's make sure the filament in that bulb is good, so I should have continuity on this side. And I do. So we know everything in the circuit is complete to ground. So if we open it up and we power up this circuit and we throw that switch, it should illuminate the light bulb. Let's try it. I'm going to hook this up. Switch is still open. Power up the power supply. And the moment of truth. And voila, the circuit is complete and the light bulb lights. So that's how you do basic troubleshooting using a DVOM. That's how I perform a voltage check to find the opening in the circuit, and that's how I also perform a continuity check. But remember, to do a continuity check, or if you want to find the resistance in the circuit, make sure it's powered down first and the circuit's open. and then you can do your basic checks like I showed you. So that leads us to the next test. Let's check the amps in this circuit. I'll show you how to do an amp reading on this circuit using the DVOM. I'm going to power down the power supply. Got the circuit open. We're going to set up our meter. This DVOM, it says 10 amps, but if you look down here, it's 20 amps, but no more than 30 seconds. So I try not to push the limit on that. So we're going to want to take it and put it on our amps. Switch this over to DC amps. Now we're going to, as I illustrated before, with a DVOM, you got to place it in the circuit. So it has to become part of the circuit. Everything has to flow through your meter in order to get an amp reading. So I open the beginning of the circuit. I'm going to hook this lead up to the power supply. That way it's going to go through the meter to this lead, which will go to the circuit. So okay, now we have it all set up. Let's do our basic amp reading. Let's power up the circuit. As you can see, it's going through the meter. And we got 0.25. We got a half an amp load on that circuit. That's how you perform a basic amp reading using a DVOM. But you want to make sure you're under 10 amps. Your circuit is rated for less than 10 amps. And I have this 5 amp fuse in this circuit, so it will never exceed 5 amps without blowing that fuse. So my circuit's protected, and plus it's protected with an internal fuse as well. But just for precautions, you want to make sure your circuit ain't capable of putting out more than what your DVOM can handle. Another way you can perform an amp reading using a DVOM is to find an open in a circuit. You don't necessarily have to open the circuit like I did in the previous demonstration. You can come back here to the schematic and we could find an open. We could either create an open by removing the fuse. Let me do that and illustrate that for you. We could simply pull the fuse out. And then insert our probes into the fuse holder. We pretty much open the circuit in another spot. So if I take and I power up the circuit, I have a good connection. As you can see, I'm checking the amps through this open in the circuit. So I just created a different open in the circuit and got the same amp reading without disconnecting the circuit from its source. I simply just removed the fuse, and you could do this in your car as well, and check the amps of the circuit by just using that open. Okay, another spot you can check it by looking at this schematic. We have another open right here at the single pole, single throw switch. As long as the switch is open, that's an open in the circuit as well. So we should be able to do an amp reading right there. Let's try it. So our switch is open. So if I take and I got it all set up for amps, this is going to bypass the switch. So now it's going to, since the switch is open, instead of going through the contacts, it's going to go through my meter and complete the circuit. 0.25. That's another spot you can take an amp reading. So as long as you can find an open in the circuit, you can check your amps. Alright, before I finish up the demonstration with the DVOM, another thing you can check is the resistance of the circuit using the DVOM. So I have it still set up for amperage. So I'll take this probe, move it back over to your voltage, ohms, resistance, continuity. So we'll set that back up. And we'll set it to our resistance. This is the ohm. That's kind of that upside down horseshoe symbol. It's for your ohms. I'll set this to ohms. It's auto ranging. But then I'll open up the circuit. And we'll check our resistance of our circuit. Simply take one lead, hook it up to the beginning of the circuit. And I'll take the other lead, hook it up to the end of the circuit. And our circuit's still open, so when I complete the circuit, that should give us our total resistance of the complete circuit. This is auto ranging, so it has to kind of go through its steps to put the decimal point in the right place. And as you can see, it's steadying out right around 4.2 ohms. So the circuit in its entirety has 4.1 ohms of resistance. And that's how you can check the resistance of your circuit using the DVOM. So if you really wanted to, like I demonstrated before, if you know the voltage of your supply, if you know your supply voltage and your resistance, you can figure out the current, the amperage, without even turning the circuit on by using Ohm's law. And that brings us to the clamp ammeter. What's nice about the clamp ammeter, like I mentioned before in the previous video, is that you can simply take it and clamp it around the conductor without opening the circuit or finding an open. You simply power up the circuit, set it to your DC amps. The lowest scale is 40 amps on this one, the highest is 400. I'm way under 400. I'm under 40, so I'll set it to 40 amps scale. Let me turn the backlight on for you. And on this one, as you can see, a lot of stray. You see the numbers fluctuating 12, 13. When you're doing DC, they recommend you to try to zero it. So what that does is just tries to hide that ghost fluctuation close to zero for you. And let me demonstrate how this works. You just simply, try to do this without getting in your way, clamp it around the conductor. And as you can see, pretty much the same range as the other DVOM, but I don't have to open the circuit. So it's a much simpler method of checking amps if you can get to the conductor. And all the other functions are pretty much the same as the DVOM. I just wanted to demonstrate the clamp style on a live circuit. Now let's find the open in this circuit with a test light. So like I demonstrated in the previous video, this one is going to be a regular light bulb style. In the demonstration I had before, I had a LED. However, I like using a light bulb because it puts a load on the circuit. So this has a certain amount of current draw. So I know if the bulb is dim, I might not have a good connection. If it's nice and bright, I know I have a good connection. So that's just one of the benefits of using a light bulb. And it's pretty much the same size bulb that's in this circuit. So if I take and I'm going to be testing the positive side of the circuit, working my way to ground to find the open. So I'm going to take the alligator clip and connect that to the ground side of the circuit. So we got that hooked up. So we come over, the bulb lights up, so I know I have power. So I go to the next thing in the circuit, which is the fuse. I have power there. I have power there. So I come down this conductor to the side of the switch. I have power there. So it should go through the switch. As long as the switch is closed, I should have power on this side. And I don't. So I know that's where I lost the power, the voltage. So that contact, the problem lays in this contact. So if I flip the switch, completes the circuit, and I have power on that side of the switch. So you can find it open in the circuit using a test light as well. I just wanted to demonstrate this pretty cool device. It's called the cable tracer. It's like the Fox and Hound that the cable company uses in other industries. But Brian from Brian's Mobile, he demonstrated one of these, a different make. This is a cheaper model. However, it basically does the same thing. And what it does is pretty cool for finding opening in circuits. Say if you're working on a car and everything's in a loom, and you have an open somewhere, a break in a harness that you're having trouble finding, instead of tearing it all apart, you can simply take this tone generator and with your circuit open, just connect this to one end of your circuit, turn it on the tone. Of course it won't be so bunched up. It's going to be a little misleading when it's so bunched up, but if you're inside a loom and everything's spread out further, the tone won't travel as far. But this will help you narrow it down. And let me demonstrate. I'm going to get a lot of interference because I have fluorescent lights in here, so you're going to hear some buzzing, but you'll get the idea. So as you can hear the pulse, the tone. My circuit's real good here. Then once I jump over to this other side, you hear how it dies down and it pretty much fades away. I know that it narrowed me down to this section right here, so I know my switch is open, so if I threw that, now it's just as strong all the way through if I open it. So it's a pretty cool device to narrow down a break in the system, and you can use it for many other things as well, but I've had it save me a few times where I had a chafe in the harness that you really couldn't see, but I was able to find it by tracing the harness, by hooking it up to my known source with everything disconnected, and I should be good from point A to point B, just like in this schematic. And I just traced it back, and then I found my open, but it could be simply just a cut in the wire. Say if this was cut through and broke, I'd hear a different in the tone on point A to point B. I noted the problem laid right there. Pretty handy. I like it. I just wanted to demonstrate that. So like always, if you enjoyed it, please subscribe. And I'm going to try not to beat up this horse too much more. Okay, I think we're going to close out this chapter with this. I hope for those of you who didn't have a basic understanding of the DVOM and some of the other basic test equipment, that it makes more sense to you now. I know a lot of you are more advanced, but to keep it fair, I had to go over this with you before we get into the more advanced troubleshooting. I'll do a couple more videos on some real-time troubleshooting before we close out this series. But I feel comfortable now we can start moving on to the more advanced stuff for those of you who didn't have a basic understanding. Stay tuned.